Assalamu alaikum students. Today we are going to talk about the probability mass function. This is week number 13. Actually, we have missed the previous week because of Eid vacations. So today we are going to discuss the probability mass function. And previous week we discussed the probability density function, which has the same concept as probability mass function, but the difference between the two is that probability mass function is for the discrete random variables, while probability density function is for continuous random variables. Okay, there is not a very significant difference between the two, but we are going to discuss both of them. In previous week we discussed probability density function. Actually, why is this called probability mass function for a discrete random variable, and the other one is for the continuous random variable, is the basic concept of mass and density. Density basically is a continuous quantity. Density of anything is basically continuously distributed among all the corners of any entity, while mass of any entity is basically a discrete quantity which always forces towards the center of the earth, or try to draw an object or entity towards the center of the earth. So this is the key difference between mass and density, and that's why due to this difference probability mass function is used for the discrete random variables. So here you can see that the probability, what is basically the probability mass function? The PMF of the random variable x is the probability that the random variable takes on the value x of j. Okay, this is basically the probability. What is the probability that a random variable gets the value of 2? What is the probability that any random variable will get a value of 3? Actually, x of j can be of any value, any discrete value. And what is x? X is a random variable. The random variable can be the heads in 3 consecutive tosses. Similarly, heads in 2 consecutive tosses. The number of you can see that the number of the days of a week in which we have a pleasant climate, and so on. This is basically a random variable, and we have discussed the concept of random variable in our previous lecture. So capital X is a random variable. While this random variable can get any value, it can be 0, it can be 1, it can be 2, or any other value. And in pleasant climate or pleasant weather example, its value can be from 0 to 7. And in the number of heads in 3 tosses, its value can be 0 to 3. So it can have any value. And the values can be of discrete nature because we are talking about the probability mass function. Okay, so here some example here some detail is listed as well. For example, if the random variable x is defined as the number of heads in the 3 tosses, you can also see that the example here is again reiterating the things which we have discussed a little bit earlier. Then the PMF of x is given by the probability that the random variable takes on the value 0, 1, 2, 3. Okay, this is the same thing which I have told you guys earlier in this lecture, that the capital X, you should have a clear understanding that what is the meaning of the capital X and what is the meaning of smaller x. Capital X is a random variable which can take on any discrete value which is represented as smaller x. Okay, so this is the whole thing, and you should know all of this. Okay, So let's move on. This is the example of a probability mass function, the same example which was discussed earlier on, in which there are three coin tosses. A person is tossing a coin 3 times. Actually, there is in 3 times. So, what is the probability of getting heads? Or the X, capital X is the number of capital X is the number of heads. The random variable we have is the number of heads. So what is the probability of getting no heads? This will be represented like the probability of tails, tails, tails. The same will happen if you will use the same procedure which I have told you, that to find the probability of any event, you should write the number of elements in the event divided by the total number of elements in the sample space. So if you write all the elements in these three crosses, you will see that there are basically total of 8 elements, and the quantity which we can see here is basically happens once out of those all 8 events. So the probability here will be 1/8. Similarly, what is the probability of getting 1 head? So it will be either you can get this one or this one or this one. Okay, that's why I am writing plus here. Okay, this plus sign basically is the indication of OR function. Either you can get this or this or this. If you are having the choice, or you can see that if you think that the same procedure can also occur in another form, so you will have to write the plus sign with those events. So writing all the probabilities, you know that the probability of this event is again 1/8, the probability of this is again 1/8, and the probability of this third is again also 1/8. So adding these three, we will get 3/8. Similarly, what is the probability that we get 2 heads? Same procedure here, 1/8 plus 1/8 plus 1/8, you will get 3/8. And out of all those 8 possibilities, you know that there is only one event in which 3 heads will occur, and this, therefore we call its probability as the 1/8. Okay, by following all the procedure which we have seen before. Okay, there is an important thing here, is that the curly brackets denote outcomes. You have to write the curly, whenever you will write the outcome of any event, you should have to use these curly brackets for opening and close, at the opening and closing of the event. Okay, so this thing is very important. So what is this? These things are called 1/8, 3/8, 3/8, and then 1/8. These are called the probability mass functions for smaller x of 0, small x of 1, small x of 2, and small x of 3. So what is this? This is called probability mass function. After it, what is the important step? The important step after it is to plot it. Actually, you have to plot the probability mass function, and the plotting basically is called the probability mass function. Whenever you will see the probability mass function, you will see its plotting as well. Okay, and at this point you should have a clear understanding of the individual probability function and individual probability of the event and probability mass function. In random variable, or in random variables and in probability mass function, you will encompass all the probabilities, all of all the possible outcomes. Okay, now you have 8 outcomes. You know that out of those 8 outcomes, you can either have 0 value or 1 value or 2 value or 3 value of the head. This is the thing which you are keeping in your mind. Okay, this thing is not fixed. Another person come and he says that okay, I am not taking my random variable as the number of heads. I will take the number of heads out of these three tosses as my as my random variable. So he will write the probabilities according to his need. Okay, so this is the example. You should keep all these things in your mind. Whatever I am doing here, these are the examples. The choice of all the outcomes or all the random variables will be your own. Okay, if you are tackling any situation, it will depend upon any situation, and in that situation you should have to take the similar random variable according to your need. Okay, here I am giving you the example that the random variable which I have chosen is basically the number of heads out of 3 coin tosses. Okay, this explanation is important because of your concept clarification of your concept. Okay, after it, what will okay, we were discussing the difference between probability mass function and the individual probabilities. So when you will plot it, you will have to plot plot all the possibilities of all the probabilities of all the possible events. Okay, so that plot is also called probability mass function. Whenever you will see probability mass function, its plot will always be there. Whenever you will see the probability density function, its plot will always be there, and out of this plot we will get different distributions. If you are dealing with probability mass function, you will get discrete distribution function. Similarly, whenever you will get probability density function, you will get continuous probability functions, and we will discuss all those probability functions later on. Okay, till now we have to plot the probabilities of the problem at hand. So this is the problem, and we have to plot it. Let's move on for this plot. Okay, this is the same thing. The PMF definition also holds if we are dealing with events within the sample space. Okay, this is the same probability function. Leave it till now. Okay, what is this? This is the property that the PMF will always be greater than or equal to 0. It is also a probability, and it cannot be greater than 1. It will either be less than, or it will always be greater than or equal to 0, or less than or equal to the 1, and its range will be from 0 to 1. Similarly, if you are to find the probabilities of all the PMF of all the events, the summation of all the PMFs will always be equal to 1. Okay, recently we saw that the probability of x equal to 0 is 1 by 8 plus the probability of x equal to 1 is basically 3 by 8, and probability of x equal to 2 is 3 by 8. Okay, and the probability of x equal to 3, where I have 3 heads, is also equal to 1 by 8. Adding them all together, these were all the possibilities. If I change the color of my pen, this is for x equal to 0, this is for capital X equal to 1, this is for capital X equal to 2, this is for a capital X equal to 3, and by adding them all together, we will get 1. You can add them and see that it will always give you 1. Okay, this is a very basic and very important property of a probability mass function. Okay, so we have discussed it now. Okay, let's move on. Okay, probability mass function. This is the same thing which we have seen earlier. It is what is the probability that capital X has a value of 0, capital X has a value of 1, 2, and 3. Okay, you can also see the difference now. Capital X, what is capital X? Capital X basically is a random variable, and small x has different values, which are the small x basically denotes different discrete values. So adding them all together, I will get 1. Okay, I have proven it in the previous slide. Let's move on. Okay, graph of PMF, I have discussed it, which is very important. Usually when we refer to PMF, we are referring to a graph of the PMF. Whenever you will see the concept of PMF, whenever you will see the concept of PDF, it will also be with the graph of the PMF and the graph of PDF. Okay, this thing should be clear in your mind. You cannot separate the concept of PMF and its graph. Okay, you cannot always write the values. Okay, you will always see the graph, its plot, and then you will analyze all the values. The graph of PMF is given by the graph of these probabilities versus x. Okay, small x, probability of x versus the smaller the small x. Okay, values that the random variable can take. The small values can be 0, 1, 2, 3 in our previous example, and their probabilities will be 1 by 8, 3 by 8, and similarly 1 by 8. So let me give you the example. Small x has values, and we have p of capital X of x. Okay, these were different values. My drawing is not that much good, but you have to see it. When the value of small x is 0, the probability of this is 1 by 8. Okay, when the value is when the value is 1, similarly we have also got the value 2, and we had also a value 3. Okay, these were the 4 values of small x, and what were the corresponding probability of PMF values? Those were 3 by 8, 3 by 8 for capital, for small x has the value of 2, and what is the probability of this? This was 1 by 8. Okay, so what you will have to do, you will have to plot this x versus this probability of x, and when you will plot it, we will see its plot in our next slide as well. Here at x-axis you will have small x, and here at y-axis you will have the probability of this x. Okay, so it will start from 0. Let me change the color of this pen. It will start from 0, and 0 will have a value 1 by 8. Okay, it will be 0, similarly 1, 2, 3, 1, 2, and 3. What is the value of 1? That is 3 by 8. What is the value of 2? That is again 3 by 8. And what is the value of 3? That is 1 by 8. Okay, so you can see that this is a basic plot. These two are 3 by 8, 3 by 8, this is 1 by 8, and this is called the plot or graph of PMF. These are all the possibilities of capital X if the capital X is the number of heads in 3 coin tosses. Okay, so you can see in this plot, you can basically see that it encompasses, it has all the possibilities. From this plot, it basically clears all the situation. What is the probability of getting 0 heads? What is the probability of getting 1 head, 2 heads, 3 heads? What are the chances? And this is the clear scenario of any situation. Okay, there is another concept, which is the expected value of this PMF. What is the expected value? Let's say this is a weight, this is the overall weight, and at which point you should keep a finger or any other thing so that you can balance it at another point. So you can clearly see that this is the point where if you can put it or a sledge or anything, you will see that it will be balanced and it will not fall to the other side. Okay, so this value is then called the expected value or the average value. This is the average value. Up till then, leave it. We will discuss it after some time, but at this point you should know that how to plot the PMF of any random variable. So we have discussed it here. Draw the PMF of the random variable x, where x defines the number of heads in 3 tosses. We have drawn it. This is the thing which we have drawn it, and let's move on. Okay, this is the graph which we have drawn earlier. This is the probability mass function of 0 heads. This is the probability mass function of 1 head, and so on. And what is this? This is the horizontal axis, and it represents x. This is the vertical axis, and it represents this one. We have plotted. How to plot it? Now you guys know. Okay, you guys also know how to plot the PMF graph for the die toss. Okay, if you are tossing a die, or if you are doing any other thing in which you have selected a random variable, so you can plot a graph of that PMF as well. Okay, let's move on. Graph of PMF, we discussed earlier that probabilities of Venn can be considered as area on a Venn diagram. Okay, we have discussed in our face-to-face class before COVID-19. So the similar concept is to think of probabilities as masses. These are the masses. Probabilities are again now masses, and this particular concept is useful when we look at the PMF of a random variable. When you will see the PMF of a random variable, you will see the overall scenario, that where is it applied and how is it important. Okay, so we have discussed it. A graph of PMF, again you can see that the important thing here is what is the important thing? You should keep a point where this will be balanced. Okay, if I remove this thing here, so it will look like this one. There is basically the axis here, that's why you cannot see it clearly. So this is for 0, this is for 1, this is for 2, this is for 1, this is for 2, and this is for 3. Okay, if you consider this a plane and these are the different masses, where should you keep a sledge or any other thing so that you should have to balance this plane? Where should you keep it? Of course you will keep it here between this, because now at this point you can see this will be balanced. Okay, so this 0, 1, 2, 3, here it will be balanced, and this value will be 1.5, and this 1.5 is called the average value. And we can see that you can find it you can find it by many methods, but you can see that we can use the method we have seen in our earlier classes, that 0 plus 1 plus 2 plus 3, okay, whole divided by the 4, because this is homogeneous. Whatever here is also here, so you can divide it over 4 and it will become 6 by 4 or 3 by 2, which is also equal to 1 by 5. Okay, this is one method. Another method, what is the other method in which we have to consider the probabilities as well. That in that method we will have to multiply these values. 0, we will have to multiply 0 with its corresponding probability, 1 with its corresponding probability, 2 with its corresponding probability, and 3 with its corresponding probability. Okay, so what will happen? 0 will be multiplied with 1 by 8. Okay, 1 will be multiplied with 3 by 8 plus 2 will be multiplied with 3 by 8 and similarly 3 will be multiplied with 1 by 8. So after adding them all together, when you will multiply them, you will get 1.5 or 3 by 2, which is also giving you the same result as there. But this is the more technical mathematical foundation which you should learn here. And what is this? This is called the expected value or average value of any random variable or of any probability mass function. Okay, so since there are equal probability matrices on the right and left of this point, so that's why this formula is also applicable. But this formula is applicable if you have similar masses or not on the both sides. This formula is applicable and you can apply it anywhere. Okay, this formula. So let's discuss the concept of expected value of x. Okay, so this is the thing which we were discussing earlier on. So I think we should stop here, and I will discuss it in our next video. Okay, so see you guys in our next video.